Welcome grade 10s. Lesson 1 here, congruent and similar triangles. Here we go. So take a minute to draw out this lesson. We're starting with congruent triangles, and we have two triangles here. And so pause the video and come back when you're done drawing this out. Okay, so you're back. We've got two triangles, and they're what we call congruent. And let's just take a look. So from A to B and D to F, those sides are identical, and we show that with these single dashed lines. And it's similar for the other sides. The bottom here matches with this bottom, and this side here matches with that side there. Okay, so that's identical. Another thing about these triangles is they have angles, and each triangle's angles add up to 180. Okay, these two triangles here, if we take angle B, it's the same as angle F, and you'd show it with the same kind of symbol. And you'll see there's various symbols. For instance, here's another symbol. Angle A is identical with angle D. And then we would also consider angle C here, which is similar with angle E. So we can see that this triangle has identical sides. We say that the corresponding angles are equal. Okay? And these triangles are completely identical. So let's summarize that. With our congruent triangles, we can note that these triangles are identical. The corresponding angles are equal. And the corresponding sides are equal. And again, we use these symbols for the angles. They're corresponding. Or maybe, how about this side? Triple dash with this triple dash. So those are corresponding equal sides. So that's a congruent triangle. And here's how we would state this with the right notation. Okay, so it's a bit of a notation in this unit that we're going to have to learn. And here it is. So triangle ABC, this one here, is congruent. So that's the symbol for congruent with triangle DEF. A couple other things we can note as far as angles in those two triangles. You would say that angle A equals angle D, and so forth. And as for sides, you write it out like this. Sorry, quick change. B is actually corresponding with F, and C corresponds with E. So we just had them reversed. Okay, so let's get this right. The sides now, sides AB, so we write it like that, is equal to side, which one, guys? How about DF? Right? Check the diagram again. Side AB equals side DF. So you got to correspond it correctly. Okay, keep going. Where we have side BC equals side FE. And lastly, we have side AC, which equals side DE. Let's do an example. So we would say something like, state the congruence. If you're given these two triangles here, so we'll just sort of draw a sketch. We're not going to draw this measured out. So here's the two triangles. Something like that. And you can kind of tell they have some symmetry. So let's get labeling them. I'll go X, Y, and Z on that one. And then I'll go Q, P, R. Okay, so we've labeled what we call vertices. Now, if they're going to be congruent, let's show you how we would associate the congruency with corresponding sides first. So this side corresponds with that side. This long side would be that side. And this side here corresponds with that one there. Okay. Again, angles, they're also equal. So pretty easy. Let's start here. This angle, identical to that angle. We would have that angle with that angle. And we could put like a star here. Okay. Normally you're given this diagram. I'm just making us draw it out. Now, if you want to state the congruence, you would be given this diagram and you'd look at this. You'd see corresponding sides, corresponding angles. They've got the identical symbols, and you would state the congruence. It's as simple as this. Triangle X, Y, Z is congruent. So this means congruent with the other triangle, QPR. Moving on to similar triangles. So if you want to draw out these two triangles, I'll give you some hints. That's 10 centimeters. That's 5. I used 40 degrees here, and then I just connected. Over here, I made this 5 centimeters, 2.5 centimeters. I made that angle 40, and then I just connected here. Go ahead and do that, and once that's done, come back. Okay, so now that you're done, let's label these triangles. They are similar. So we'll go with A, B, C, and we're labeling what we call vertices. Okay, that's this way. So triangles have what's called a vertice, they're endpoints. And the other triangle is going to be D, E, F. Okay, if you have similar triangles, they're like scale models of each other. They are not identical. They are essentially some scale of each other. That would be no different than the following. So check this guy out. He, hopefully you know him. He's got a certain size to him, right? His name's BB-8. And see if I can wake him up. Come on, BB-8. There he is. There's BB-8, all right? And along comes this guy. He's also BB-8, but he's smaller. So he's a smaller scale version. So that's what similar triangles are. It's like a scaled version. Okay? See you, buddy. Okay, so in the similar triangle situation, the way you would label this and show this, you have the following. Okay, so what we have, BB-8's still talking. Here we go. Angle B, let's show it as an open circle. And over here, in the smaller triangle, that angle is the same. And it's same for the other angles. Angle A, I'm going to have to turn him off. BB-8 is making too much noise. He's noisy. Okay, back to this. Angle A is angle D. And angle F, let's show it as an arc. And it's arbitrary. You can choose whichever symbol you want as long as they correspond from triangle to triangle. So I could use like a star here and then put a star here. Okay, so there you've got the angles. They're equal. So angle B is equal to angle E, angle A is equal to angle D, angle C is equal to angle F. Okay, the sides aren't equal though. So we can't show those dashes, the sides are not equal. They're what we call proportional. So as far as the summary for this one, would be the following. The angles, you can draw an angle like this. Earlier I did it with the dash through it. You can also draw it just like this. I'll stick with the dash, I guess. So angle A is equal to which one? Angle D. Angle B, and so forth. Okay. Since the sides aren't equal, it's a bit different. We'll do the following. Now, here's the thing. Since it's got a scale factor, the sides are what we call proportional, and it would look like this. So length AB over length DE, that's going to create like a scale or a ratio, and it's all going to equal out to the other sides' ratios. So AB over DE is going to be the same ratio as BC over EF. Same goes for AC over DF. Okay, so if we had actual numbers, we could work out the scale of this triangle, which is usually something we end up considering. The notation we use to show that these are similar triangles is a bit different than what we had earlier for congruent triangles. Here it is. So triangle ABC is similar, so this means similar to triangle DEF. So something to note, these are the ratios, and it creates like a scale factor. So maybe this triangle's half the size of that one, or maybe this triangle's 1/3 the size of that one. That would be the scale factor. So 2 for half, or if it was a third, the scale factor would be a 3. Moving on, we're going to look at ratios. So what's a ratio? Let's do an example. Let's say a class has 20 girls and 15 boys. Let's find the ratio of girls to boys. So take a minute to take this example down and come back when you're ready. Okay, here's what you do. If you want to know the ratio of girls to boys, look like this. If you got girls, we just put the colon there, to boys, and we would write it like this. It's 20 for girls and 15 for boys. You can actually write this as a fraction, where 20 is the numerator and 15 is the denominator. So as a fraction, it would be 20 over 15, which we know we can reduce, and you should do that. What can we do? We can put, each can divide by 5. So 20 divided by 5, 4, 15 divided by 5, 3. So the ratio of girls to boys is 4 to 3, or 4 over 3. We're going to look now at using proportions. So let's take a different class. And this class has a girls to boys ratio of 3 to 4. So that means there's 3 girls for every 4 boys. You have to read this in order. It says girls to boys, so that's girls to boys. And then there's known to be 18 girls total in the class. How many boys are there? Well, you have to set up what's called a proportion. Okay, so let's do that. Here we go. Basically, a proportion is using several ratios. So here we go. Here's the proportion. The first ratio, well, we've got girls over boys. And we know that that's a ratio of 3 over 4. So we make the girls match with the girls, the boys with the boys. But we also have another piece that's known. We know that the girls in this class, that's known. We're told there's 18 girls. Okay, so let's put 18 girls. And we don't know how many boys there are. So instead of boys, we'll call it X. Okay, and that equals 3 over 4. So we've got what now we have like two ratios, 1, 2, and together they make a proportion. So this whole thing's a proportion. And to solve the proportion, you need to do what's called cross multiplication. Let's show you cross multiplication. Essentially, you make like a cross where 18 will multiply 4 and x will multiply 3. And here's how you set it up. So what's 18 times 4? Does that show up? 18 times 4, 72. So 18 times 4, I'm going to write that answer actually over here. And then I'm going to do x times 3. X is the unknown amount of boys. X times 3, there's 3 x's. Okay? Then to undo 3 times x, you have to divide out that 3. And be fair to the other side, you have to divide by 3 there as well. That cancels. X is left. 72 divided by 3. That's 24. So it turns out there are 24 boys in this class, along with the 18 girls. Next up, let's talk about similar triangles with proportions. So say you have two similar triangles. If we happen to know the ratio for one of the corresponding similar sides, we can then determine other unknown side lengths. Let's show you this with an example. Okay, so let's say you have example 1 here, and you're given those two similar triangles. So take a minute to pause the video, draw this out, and we'll come back. Okay, so now that you've drawn this out, first question is state the similarity. You have to be able to look at these two similar triangles and make sure that you get the corresponding sides correct and the corresponding angles correct. Okay, so if we look at dark dot here, find him over here, there's the dark dot over there, and then the open dot with the other open dot, so looks like side PQ is going to be similar to NL. And you keep doing that for the entire triangle. For instance, side PQ is 10, and then we have side LN is 5. So it looks like side 10 versus side 5, they're corresponding, and 10 over 5 is a scale factor of 2. So though this is not drawn to scale, these two triangles are actually a scale factor, one's double over the other. So to state the similarity, you would do the following. Okay, triangle, remember earlier we said triangle PQR is similar, that's the symbol for similar, to triangle LNM. And usually in an example, you're just given the info and you can see that the triangle is similar from all the different symbols we talked about. And it's just a matter of showing this with the correct notation. So next part I'll set up here is some calculations to find unknown side x and y using proportions. Next part asks, find sides x and y, and you have to use proportions. If we look at both triangles, we can see here that side LN compared to side PQ, there's no numbers. So you want to look for that. And we can create our first proportion that gives us the triangle's ratio. So LN over PQ is one ratio. That's part of the proportion. And here it is. So LN is 5. PQ is 10. Which we can see that that reduces to a half. With the ratio of a half, anytime we compare corresponding sides, we expect them to have a relationship of a half, or you can look at it the other way and you could say double. So let's find x now. Okay, so since we're going to try and find x and he's in this triangle, let's set it up like this. We know from this triangle, side 5 corresponds with this triangle's 10. So we're going to write that out. Just going to adjust here. Okay, so 5 goes with 10. X now, who would he go with? Well, he's on side open circle and this arc. So over here, X seems to go with 12. So you write X over 12. Now you just have to solve this using that cross multiplication from earlier. So 5 times 12, I like to write it on this side, that's 60. 10 times x, that's 10x. Divide and conquer. It means to divide out what's in front of the x here, so it cancels. And you're left with x would be 6. So why don't you try y, and I'll do it here in a sec. Pause and try and come back. To find y, you'll still need that scale factor, or the ratio that we originally found. So 5 over 10. You got to have the right order now. Now that you started with 5 here, the next part of the proportion, you'll have to put the y down. And this y corresponds with 15. So now you write 15, and you have to solve. And you solve again by cross multiplying. So go ahead and try that if you didn't get that far. I'm going to work it out now. 5 times 15, what's that? 75. 10 times y is 10y. And divide and conquer. And y is 7.5. So now we've solved for unknown sides using proportions and similar triangles. I'll leave you with this example to try here. So again, 2 similar triangles. You have to do the following. State the similarity in part A, and then in part B, find x and y. So refer to what we did in example 1. Pause the video, try it, and then after, check your answers with the video. Okay, here are the answers. So part A, state the similarity. You got to get the order right. So if you call this triangle A, B, C, so triangle A, B, C, and you want to say it's similar, you've got to get the right order of letters in the second triangle. So A, B, C, okay? Really, you should say it's similar to triangle. Let's go. A is the pink arc, so that's E. B is the green dot, so that's D. And then C is last, so you'd have to say triangle E, D, C. Just good form to do it this way. To get into part B, you need to work on finding the ratio first. So let's compare corresponding sides and see if we can find this triangle's ratio or scale factor. Okay, so that's, from here's a 5, that's the arc to the O, and here the arc to the O is Y, so that won't work. What about green dot to red circle, to circle here? That's 7.5, and it looks like over here from C, where the circle is, to that green dot there, that's 3. So that's how you're going to find this triangle's ratio. You're going to say the following. You're going to say that BC over, you could say DC, right, is 7.5 over 3. Okay, and then we can leave that like that, and you move into finding x. So to find x, now, remember, x is in the bigger triangle over here. So set up your ratio, 7.5 over 3. Now where's 7.5? He's in the big triangle. So make sure when you write x down, he goes on top, because it goes big triangle, smaller triangle. So over here you got to go big triangle over the corresponding side that x has in the small triangle, which is 4. Okay, and then that becomes cross multiplication. So let's write it out, 3x, and 4 times 7.5 is 30. And then again, you just divide. X equals 10. Do side Y. Put your ratio in, 7.5, the larger triangle, over 3. Go find the larger triangle and relate it with Y in the smaller triangle. So here's Y in the smaller triangle. And if it's smaller, then Y has to go here. Okay? And then go find who Y is in the bigger triangle, and it works out to be 5. Okay, now you cross multiply. So 7.5 times y is 7.5 y. I just did that part of the cross multiplication. 3 times 5 is 15. And divide and conquer. And you can skip a step. You can just show you're obviously dividing 7.5 out there. Divide it out over here, and you end up with 2. And there you have it. You found, using similar triangles and proportion, unknowns. And that concludes this video. Thanks.